goal of this lecture. After a long day, today I will discuss some example of inner product space. Because this type of question and concept of inner product space actually very important for higher study. This is our goals of today's lecture. Today I will introduce some question which had come different type of competitive exam. Let's see our first question. First example, which had come CSIR Net June 2023 exam. This question, which of the following be inner product space? The question is, let x equal to x1, x2, xn and y equal to y1, y2, yn denote the vector in R. Then for a fixed vector n greater than equal to 2, here n is greater than equal to 2. Then which of the following define an inner product space on Rn? Option 1, here summation ij from 1 to n xi yj. For short calculation, consider n equal to 2. That means inner product xy would be x1 y1 plus x1 y2 plus x2 y1 plus x2 y2. This is the first example. Second example, inner product xy equal to summation ij from 1 to n xi whole square plus yj whole square. And this is equal to, since I have considered n equal to 2, that means this would be x1 square plus y1 square plus x2 square plus y2 square. This is the second example. Third example, inner product xy equal to, here summation j varies only j equal to 1 to n j cube xj yj. Since I have considered it n equal to 2, so these would be x1 y1 first, because here j equal to 1, then this would be plus 8 x2 y2. Fourth, inner product xy equal to summation j equal to 1 to n xj y n minus j plus 1, and this value would be x1 y. Here I have considered n equal to 2. 2 minus 1 plus 1. That means this is would be x1 y2 plus, when j equal to 2, x2 n equal to 2, that means this value would be x2 y1. This is the fourth. Now we have to check which of the following be inner product space. And we all of us know inner product space means it satisfies first distributive property, second linear property, third symmetry means symmetry conjugate property, fourth positive definite means when inner product x with x greater than 0 means always x not equal to 0, and inner product x with x equal to 0 if x equal to 0. This is the condition. This is the condition of inner product space we all of us know. Now I will say, for this example, which type of condition applicable to break the inner product space? To check inner product, the shortcut trick is, at first, check the positive definite part. Here, inner product x with x means given x1, x2 times y1, y2, to define the positive definite part, inner product x with x. Inner product x with x, that means this is equal to this would be x means x1 comma x2, therefore this value would be x1 plus x2 times x1 plus x2, which is equal to x1 plus x2 whole square. And notice inner product x with x always strictly greater than 0. Therefore, first part of positive definite true when x not equal to 0. But if x1 equal to minus x2, then obviously inner product x with x would be equal to 0. But notice here inner product x with x equal to 0, but x not equal to 0. Here x1 inner product x with x equal to 0 when x1 equal to minus x2. Otherwise this is not equal to 0. Therefore I have got for non-zero value of x, the value of inner product is equal to 0. So this condition has broken the condition of inner product. So I hope my all viewers have understood. So option 1 is a wrong option. Option 1 not be inner product. I hope my all viewers have understood this is okay. And option 2, notice inner product x with y equal to here x1 square plus y1 square plus x2 square plus y2 square. x1 square y1 square plus x1 square plus y1 square plus x2 square plus y2 square. This type of equation always would be break the linear condition, because this type of equation square part not satisfy the condition of linearity. This type of equation not be linear. So just check this linearity condition. Product alpha x with y, this is would be, notice alpha square x1 square plus alpha square x2 square plus y1 square plus y2 square. This is not equal to alpha times inner product x with y. Therefore inner product alpha x with y, this is not equal to alpha times inner product x with y. So option 2 also not be true. Therefore option 2 also wrong option. I will see is the fourth option is true. At first I will see the fourth option. Fourth option indicate inner product x with y equal to x1 y2 plus x2 y1. At first I will check the positive definite part, because actually to check inner product more question would be solved by this positive definite part. By this positive definite part more question would be solved. For positive definite x with x, inner product x with x, and for this inner product x with x would be 2x1 x2. Here we have to check for inner product condition, this value always would be greater than 0, strictly greater than 0 for all non-zero x. But if we consider x1 equal to, if we choose x1 equal to 1 and x2 equal to minus 1, then this value would be minus 2 and this is less than 0. So inner product x with x, for this value I have got this value is less than 0. Therefore positive definite part has broken here. So fourth option also wrong option. This is not be inner product. That means option 3 only right option. Just check it own self. It will satisfy the all property of inner product. This type of concept and this type of question actually very important for all competitive exam. Okay. Our next question, because I have told you few minutes ago, today I will discuss only question similar type of example. Which of the following is or are inner product on R2? Option 1. Inner product x1 y1 with x2 y2 is equal to x1 y1. Option 2. Inner product x1 y1 with x2 y2 equal to x1 square plus y1 square plus x2 square plus y2 square. Option 3. Inner product x1 y1 with x2 y2 equal to x1 y1 cube plus x2 y2 whole square. Option 4. None of above. Which of the following would be true? Similar type of first option. First, I have told you many times to define inner product, to check inner product. At first check the positive definiteness. If in positive definiteness there exists no break, then approach in further option. First, inner product x1 y1 with x2 y2 with x2 y2 given x1 y1. Here I will use the positive definiteness. That means for positive definiteness, x with itself, here this value would be obviously x1 y1, and if we consider 1 0 vector with 1 0 vector, this value would be 0. Here notice x with itself is equal to 0, but the x is not equal to 0. This vector is not equal to 0. So, first option has broken the positive definiteness. So, option 1 is a wrong option, and option 2, this type of example always would be broken the linearity condition, because first question I have told you this part, this type of question always, this type of square term, this type of question, this type of equation always would be broken the linearity condition. So second option also wrong option. Third option, for this also at first check the positive definiteness. x1 y1 with x1 y1, this value would be x1 y1 cube plus x1 y1 cube. That means value would be x1 y1 cube plus x2 y2 square. So if we consider x1 equal to 1 and x2 equal to minus 1, then this value would be minus 1 plus, not x2 here, y1 equal to minus 1, this value would be minus 1 plus 1, this value would be 0, but the vector x1 y1 be not equal to 0. Therefore I have got inner product equal to 0 for non-zero vector. So this is also broken the positive definiteness. So for this option 3 also wrong option only. That means none of above be inner product. Have you understood? To define inner product, at first check the positive definiteness property. If we can no conclude about inner product by positive definiteness, then go another option, another further method. Okay. Next example, which had come CSIR NET June 2023 exam. The question is, let n greater than 1 be fixed natural number, then which of the following is an inner product on a vector space of n cross n real symmetric matrices? Option 1, inner product AB equal to trace of A times trace of B. Option 2, inner product AB equal to trace of AB. Option 3, inner product AB equal to determinant AB. Option 4, inner product AB equal to trace of A plus trace of B. Which of the following be an inner product space? Similar to before, I will check at first the positive definiteness. First, inner product AB equal to trace of A times trace of B. For this, consider the matrix A equal to 0, 1, 1, 0. Then, inner product A with itself means trace of A times trace of A, and here trace of A means 0 times 0, which is equal to 0. Therefore, this break the option 1. So, option 1, therefore, I have got inner product A with itself equal to 0, but AB non-zero vector. So, option 1 is a wrong option. Next, notice inner product A with B is equal to trace of AB. For this type of inner product always satisfy inner product, because this is the standard inner product. Next, inner product AB equal to determinant of AB. For this, consider the matrix A equal to 1, 1, 1. And notice inner product A with itself is determinant of A square, and determinant of A square means this is equal to det A whole square, and det A means this is 1 minus 1 0, 0, but here A is non-zero vector. So, option 3 also wrong option. Next, consider A equal to 0, 1, 1, 0. Then, inner product A with itself is equal to, since defined as trace of A plus trace of B, that means this would be trace of A plus trace of B, trace of A. Here trace of A equal to 0 plus 0, which is equal to 0. But A is non-zero matrix. So, this inner product also would be broken. Have you understood why positive definiteness is very important to check inner product? I hope my all viewers have understood till now. Okay? Today I will stop here. In my next video, I will define another type of inner product, because inner product actually very important for higher study, also for all competitive exam. Okay? See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.